Hello students, in the new series Basics Explained, I take you through the basics of different topics. Today we are looking at math and we are focusing on statistics, sampling and probability. This video is basically geared towards SAT math questions. So the focus would be questions that you're likely to see on SAT math from this topic. So when we talk about statistics on the SAT, there are some terms that you should know and be comfortable with. The first term being mean, which is also known as the average. So let's say I have a data set A, -7, 2, 3, 44, and 52. Then the mean is the sum of the elements divided by the number of elements, right? So that's -7 plus 2 minus 5 plus 3 minus 2 plus 44, 42 plus 52, which is 94. 94 divided by 5, since there are 5 elements, would be 5 ones are 5, 44, 5 eights are 40. So that would be 18.8. So the mean is just the sum divided by the number of elements. Okay, the median is the central value. So let's try and find the median for this. Now for the median, we need to look at the number of terms, right? If the number of terms is odd, then the median would be, let me write that, when the number of terms n is odd, then the median is the n plus 1 by 2th item. What does that mean? So here I have 5, n is 5, which is odd. So my median would be the 5 plus 1 by 2th item, which is the third item. Because 5 plus 1 is 6 divided by 2 is the third item, which happens to be 3. So my median for this data set is 3, right? What if the number of terms is even? What happens then? Let's look at that. So I'm just going to clear this. And I'm going to add another term to this term so that I get an even number of terms. So let's say I add 60. And now I have 6 terms. So when n is even, then the median is the average of n by 2 value and the n by 2 plus 1 value. What does that mean? So here n is 6, right? So the median will be the average of n by 2, which is the third value, and 3 plus 1, the fourth value. So the median would be the average of 3 and 44, which is 47 by 2, which is 23.5. So then the median is 23.5. You notice, interestingly, when the number of terms is even, the median does not have to belong to the data set, right? Because here 23.5 is the median, and that is not a part of the original data set of 6 terms. Okay, let's go to mode. The mode is the most common value in a data set. So let's say I have a data set of 2, 3, 3, 4, 4, 4, 6, 6, 7, 7. Then I notice that 2 occurs once, 3 occurs twice, 4 occurs 3 times, 6 occurs twice, and 7 also occurs twice. So the most common is 4 because it occurs 3 times. So the mode is 4 for this data set. Now, let's say I did not have 3 4s. Let's say my data set looked like this, right? Which is to say that I only had two 4s, right? In which case, each of the other items, 3, 4, 6, and 7, each of them occur twice, which is the highest number of times an item occurs. And so the modes are 3, 4, 6, and 7. All 4 are modes because they occur the same number of times, the highest number, which is 2. Okay, let's say everything occurred once. Let's say I had a data set like this. I had 2, 4, 7, 9, 11, 16. This does not have any modes because every data point occurs once, so there are no modes. Okay, then we have something called the range. What do we mean by the range? The range is simply the difference between the largest and the smallest value in a data set. So for example, if I look at the data set given here, the smallest value is 2 and the largest value is 16. So the range is 16 minus 2, which is 14, right? So that's what range is. Right, and standard deviation is indicative of spread of data. And on the SAT, you would need to compare standard deviations of two data sets. For example, let's say I have a data set made up of 8, 8, 9, 10, and 12. And another data set made up of 8, 12, 15, 23, and 28. So what standard deviation captures is how far data values are spread from the mean, right? So for the first data set, let's call it A, 8, 8, 9, 10, and 12. Let's say the mean is 9. I don't know the exact mean, but let's say it's 9. It's somewhere. So the spread is on the left is going till 8 and on the right is going till 12, right? That's the spread for A. If you look at B, which is 8, 12, 15, 23, and 28, and let's say the mean for this is 17. Again, I don't know if that's the mean, but I'm assuming a reasonable assumption. Then here the spread is going till 8 on the left and 28 on the right. So I can see that the spread from the mean is lower for set A compared to set B. In set B, the spread from the mean is higher. And so the standard deviation, which is denoted by sigma, standard deviation for B is greater than the standard deviation for A. Standard deviation of set B is higher because the elements are much farther spread from the mean compared to the elements of set A. You also have a statistics formula for standard deviation that you may have done in school, but you won't be required to use that on the test, on the SAT, because it's a long formula, lengthy formula, and you don't have the time to implement it. You would only be required to compare standard deviations of two sets. Okay, so let's do some problems. After her third English test, Gauri's average test score was 88. What score does she need on her fourth test in order to have an average of 90? Okay, so let's say T1, T2, and T3. These are the three scores. And the average for these three was 88, which means T1 plus T2 plus T3 divided by 3 is 88. So T1 plus T2 plus T3 is 88 multiplied by 3. And let's say that Gauri needs to get T4 on the fourth test, and then her average is 90, which is to say T1 plus T2 plus T3 plus T4 divided by 4 should be 90. Or T1 plus T2 plus T3 plus T4 is 4 into 90, which is 360. Now we know that T1 plus T2 plus T3 is 88 into 3, and that plus T4 is 360. So T4 would simply be 360 minus 88 into 3, which is 4 carry 2, 264. and that's 96. So Gauri needs to get 96 in the fourth test for her average to go up to 90. Okay. Let's try another sample question. At a fundraiser, 25 people donated an average of $50 each. So let's write that down. 25 people donated $50 each, and 15 people donated an average of $100 each. What was the average donation for the whole entire fundraiser? So what's the total for this 25 people? That's 25 into 50, which is 1250. And the total for this 15 people is 1500. So the total contribution that came in through the fundraiser becomes 1250 plus 1500, which is 2750. That's the total. And the total number of people at the fundraiser was 40, 25 plus 15. So average donation to the fundraiser will be 2750 divided by 40. The zeros cancel out. 4 6 are 24, 35, 4 8s are 32.75. So the average contribution per person at the fundraiser is $68.75. Okay, so that was this question. Right, in this question, we've been given a data set, the most recent exam scores for a class. We have been asked to find the median, the mode or the modes, and the range. So we already have the data set in ascending order. So the range will simply be 98 minus 64, which is 34, right? How many terms? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 terms. So the median will be the average of fifth and sixth terms, which is 1, 2, 3, 4, 5, 78 and 83. 78 plus 83 by 2, 161 by 2, which is 80.5. So the median is 80.5. And the modes, so 64, 72, okay, 78 occurs twice, 83 occurs twice, and all others occur once. So there are two modes, 78 and 83, because they occur twice. Okay, so that was this. Right, now we have two data sets. Which set has a larger standard deviation? So let's say that the mean for this data set is, let's say, 36. So my spread goes until 32 on the left and 39 on the right, right? And basically the clustering around the mean is less, right? Less clustering around the mean, right? Here, let's say my mean is 35 and there's a lot of clustering around the mean and the spread is less. So more clustering around the mean. So since this is more clustered around the mean, sigma B would be less. And since this is more spread out, sigma A would be more. So which one has a larger standard deviation? Data set A. Okay, that's question 4. Okay, when it comes to sampling, you need to keep a couple of things in mind when you're asked to apply the results of the sample to a population. Basically, the first thing is that the sample should be representative, which means that if you want to talk about the population of a town, then you should only take samples from residents of the town, right? So it should be a representative sample. Sample size plays a role in the sense that the larger the sample size, the more accurate the prediction. So the margin of error can be lowered by taking a larger sample size. And the most important is that your sample should be random, right? You should not take a biased sample because that will skew the results. So let's say I have a question about sampling. A town newspaper polled 500 voters selected at random from a list of all registered voters in the town. Of those polled, 41% approved of their state governor's performance. Which of the following is the largest population to which the results of the poll can be applied? So there are 500 voters from a town who are polled about the state governor's performance. So the first two options, A and B, the people who received the newspaper and people who participated in the poll. These are small populations, right? People who participated in the poll is the sample itself. So it doesn't make any sense to have a sample if it can't be applied to the correct population. So these are not correct, A and B, right? I should be able to apply the sample's results, if the sample is random, to all the registered voters in the town, right? In the state would be too large population because other towns will have other issues and we don't know if other people, other towns will have a similar response to the governor's performance. So the right answer is option D. All registered voters in the town is the correct population to which the sample results can be applied. Okay. And then when we come to probability on the SAT, you're most likely to see tabular data and the ratio of favorable outcomes to total outcomes as calculated from a table. So let's say I have a table here which has people who have traveled abroad and not traveled abroad here. So the total number of people is 45 who have traveled abroad and 82 who have not traveled abroad. And the other way I have distinguished between members is on the basis of age, under 20 or 20 or older, right? So if a person is chosen at random, meaning I'm not putting any condition, so my denominator would be all possible participants, 127. What is the probability that he or she is under 20 and has not traveled abroad? Under 20 and has not traveled abroad. So that's 44. So my denominator is all the possibilities, and the favorable possibilities are the numerator. If a person is chosen at random from those who have traveled abroad, so now my denominator will be 45 because I'm only looking at those who have traveled abroad. I'm not looking at the others. From this group, what is the probability that he or she is 20 or older? Which means this. From the traveled abroad group, 20 or older is 27. So my answer is 27 by 45, which I can simplify to 3 by 5, right? 9 3s are 27 and 9 5s are 45. So that was a quick primer on statistics, sampling, and probability for the SAT. This is part of a new series in which I will upload the basics of various topics that you need to know for the SAT and for the ACT. Hope you found the video useful. If you did, please hit the like button and subscribe to the channel. Remember, if you share it with your friends, then your friends may benefit as well. So please do that. I'll see you guys in a new video soon. Take care. Bye-bye.